start with 3 worker nodes. You have more traffic, you add the fourth one, fifth one, sixth one. Once the traffic is gone, you just remove those nodes. So that is horizontal autoscaling. You just add, you throw more and more bodies, at the problem. Vertical vertical scaling is slightly more complicated. It deals with actually mutating the resource itself, right? So if a pod initially requested, let's say 1 core and 4 GB, you can say that when there is more load, give it 4 cores and 16 GB, right? The same pod itself. And we'll see later in the book, this is usually a mutating change, right? So Kubernetes does not allow, or even the cloud providers do not allow you to change the number of cores or the memory available for the resource at runtime dynamically. Right? You have to create a new machine, destroy the existing machine and create a new machine, or maybe stop it and resize it, right? Same in Kubernetes, your pod will actually get recreated with new resources, requests and limits. I've not seen vertical scaling or VPAs being used that often. I mean, we explored it once, but then we decided not to go with it. But yeah, in theory, it is possible. There's one more challenge with vertical scaling, and that is the underlying hardware on a machine is fixed, and you are bound to that limit, right? So even if, let's say, you start with a T2 micro, you keep on scaling up T2 small, medium, large, extra large, 4XL, 16XL, but there'll come a point where you won't be able to vertically scale anymore, right? There are physical boundaries to it. Compared to that in horizontal, I mean, there's much more flexibility, right? You can create much more machines and you can have much more capacity, but then your application should support it. So that's about horizontal and vertical. There are a few points about application architecture. So I think we already discussed that microservices are kind of an ideal use case for auto scaling, right? If you are into this microservices architecture, if your company and organization uses that and have adopted it, you might be needing auto scaling, right? For example, if you have a web application and a blog engine for your company, if you run a campaign, you might just want to scale up the web application instances and let just one pod for your blog serving engine be running, right, independently of each other. Another consideration with respect to architecture is your application ideally should be small and nimble, right? It should not be a bloated application which requires a 10 GB Docker image or a container image to be downloaded. And if it takes like 3 minutes or 5 minutes to just initialize and do the cold boot part, your whole auto scaling chain will be slow to respond. So if you have smaller components, which let's say have a 200 megabyte image and which the container spins up in, let's say, a second, that's an ideal case, and it responds better, right? Your application responds faster to the events of auto scaling. Next is an issue that is not mentioned in the book that, but I faced it at multiple places, which is about the shared caching. So if your application deals with any kind of cache, it's ideally better to store those, cache related data in an external cache like Redis and not use any libraries. So for example, we had a client with a Node application, which was using some Node uh, module that allowed caching on the system memory itself, right? And they just had one pod, and the moment they went with they scaled up and went to 3 pods, there were intermittent failures in the application. Whenever the user refreshed, they used to get logged out, right? Because they were using the system memory to store the session data. So if you're using auto scaling, make sure that any cache data is kind of decentralized and stored outside of the system and not on the system memory. And finally, your application should also support graceful shutdowns, because whenever autoscaling happens, when it scales out, which means when you add more machines, add more pods, that is fine. But you also have to remove those machines and pods when the demand is gone, right? Once the demand is low. And in that case, it should not happen that any active requests get impacted. So your application should basically support a graceful shutdown whenever it receives that signal. It should uh, stay awake for let's say 30 seconds or a minute, and allow the sessions to drain, and then gracefully shut down. Okay. Uh, Cool. So there are two types of autoscalings that are discussed here. One is the workload autoscaling, which is your applications and everything that runs on top of Kubernetes. And then there is cluster autoscaling. So things that Kubernetes runs on top of, right? So like your worker nodes, etc. So talking about workload autoscaling, there are two components, two major components, right? HPA and VPA, horizontal pod autoscaler and vertical pod autoscaler. I think they've given a very good diagram here. Yeah. So HPA has so when you want to use HPA, you can submit. So if you look at this code example, you have this deployment YAML, and along with that, you bundle a horizontal pod autoscaler object as well, right? In which you define that I want minimum one pod to be running for this particular deployment and maximum three pods, right? But what is the criteria? Criteria is CPU utilization percentage. So whenever the percentage CPU utilization is more than 75, Kubernetes will add one more pod until you have three pods running, right? It will not go beyond that. And whenever it goes below 75, it will try to remove a pod and eventually remove a pod from your cluster. And the component that takes care of that is the HPA controller, right? So HPA controller will talk to metric server, which gets the CPU and memory. So CPU and memory are the only two metrics, as per my knowledge, which are available by default through metric server. If you want any custom metrics, you have to use external adapters and an external a monitoring system like Prometheus or Datadog, which is discussed later. But by default, you can auto scale based on CPU and memory usage. And not just that, you can also combine CPU and memory both metrics here, right? So you can say that if CPU percentage is more than 75 or memory percentage is more than 90, if either of the threshold is breached, Kubernetes will scale up uh, and accordingly also scale down. I'm guessing most of us must have used HPA here, right? Anybody who's not used HPA?
I have not used HPA. So, okay, let me give a background. So, I've worked on systems where my current organization is trying to adopt Kubernetes. It was not Kubernetes in production as of now. So, I've joined this session to understand how it is.
Mm-hmm.
So, that's the background. So, I haven't used HPA, but I've known it.
Mm-hmm.
I've known, okay, what it does, etc.
Got it. Cool, that's fair. But eventually, sooner or later, you'll bump into HPA, so
Exactly,
don't
exactly.
worry.
Yeah, yeah.
We all meet the same fate. Uh, yeah. So although this all sounds good, but in my experience, this kind of setup is not sufficient in kind of today's architectures that we started building. Because CPU in itself is not a leading indicator; it's more or less a lagging indicator, right? When your CPU has already breached 75% or 80% or 90%, things have already gone south, right? It takes some time for your CPU to kind of respond to that. It's ideally better to use some kind of an external metric. And I've found the HTTP request count metric to be fairly good enough, right? The throughput count. If you use that, you get much better performance and a much better experience compared to the default CPU utilization. Just give me a minute. Yeah, sorry about that. That was my mom. So, anyways, this default setup is good enough. Is good but not good enough. That's what I'm trying to say. So let's move on. Not all workloads can scale
I don't think
horizontally.
this particular book talks about KEDA, right? It doesn't talk about KEDA,
No,
right?
no, it doesn't talk about KEDA. I will mention, but I think we should cover KEDA separately.
Sure,
Full
sure.
session. Yeah. So in the custom auto scaling part, I thought I'll just drop in about KEDA. And I guess KEDA is become pretty popular. Almost everybody is kind of using it, and it's good enough. It's much better than the default. So yeah, talking about HPAs, not all workloads can scale horizontally. A very good example of that is your MySQL server, right? Uh, Here they say that stateful workloads, leader-related applications, uh, but MySQL is a stateful workload, right? So if you have a MySQL server, if you just scale it up, and if you have two instances of MySQL servers, it's just not good enough, right? Because half the writes go here, half the writes go there, unless you have a leader election, unless you have a primary MySQL, all the writes go there and get replicated. So you can't just use HPA for everything under the sun. But for all kind of stateless applications, it's fairly good, right? It just works. Next, cluster size will limit scaling. Okay, so HPA, like we saw here, right? So this is about the workload auto scaling. This is about the pods that are running on the cluster, right? Your applications. Now, if you say that I want min one max three instead of min one max three, tomorrow you would say that let's scale it up. I want min three and max 40. Uh, okay, your Kubernetes HPA will try to add more pods, but if you don't have the underlying CPUs and memory, if you don't have the underlying worker nodes with that much capacity, just having HPA is not going to help, right? You will also have to ensure that your cluster also gets auto-scaled, up and down. And yeah, CPU and memory may not be the right metric. So this is, I guess, what we discussed, right? Uh, your CPU and memory may not be the best metric in today's world to auto-scale. There's one more gotcha around this. So there are some legacy applications or there are some apps which might spike during the booting phase, right? The initialization phase, the CPU usage or memory usage will just spike up, and then once the application has booted, uh, things will normalize. All right. So in that case, uh, what can happen is your HPA might see that as a normal usage, right? Your usage has spiked, and it might try to add one more pod. Again, in that pod, the usage will spike, your HPA will scale up, and it will say it will add one more pod, right? So you might get into a loop there. These things are configurable, but these are configurable at a cluster level, right? So, for example, this setting, the horizontal pod autoscaler, so let's call it initialization period. So you can configure the initialization period. You can just give a cool off time that just wait for 2 minutes and then start, the whole HPA wala process. You can also set the sync period. So by default, I guess somewhere it's mentioned that the HPA will poll every 15 seconds, but you can also configure that. But like I said, these settings are cluster level. And again, these I'm not sure if this is still true today. This book is pretty old, and honestly, I've never had to go and tweak these settings, right? But there might be use cases, right, where you might have to control these kind of metrics in such use cases. So it's always good to know that there is an option to configure that. All right, vertical pod autoscaler. Any experiences with HPA? Anything that you would want to just drop in? Any comments? Any production issues you face because of misconfigured HPA? Nothing. Cool. So VPAs, vertical power autoscalers. Now VPA is slightly more complicated. Essentially, it is the same, right? It polls for the resource usage. If the usage goes up, it makes some changes to your application. But instead of adding a new pod, what it does is it mutates the existing pod itself, right? So if the requests, let's say you start with request 500, like half a core and 1 GB, and you say that max this pod can go up to is 2 cores and 8 GB, right? So it keeps the pod intact and just mutates the pod resource itself instead of increasing the count, right? So there are three major components in VPA. First is the recommender, which would determine what is the optimum CPU that I should now set for this pod, right? Again, it queries the metric server, and metric server gets the data from kubler, right? So your VPA recommender will keep pulling your metric server regarding the usage, and based on whatever you configured in the VPA object, it will come up with a value, right? The desired value, the desired state. The next component is admission plugin. This part basically goes and mutates your pod resource, right? It would make the actual change in the pod. And finally, there is the updater, right? Uh, Updater, I'm not sure why the name is updater, but it makes sure that once Kubernetes has determined what is the desired request and limit for this particular pod, it evicts the pod, the existing pod, so that a new pod can come in with the new values, right? So like we discussed earlier, VPA does not happen in place. Vertical scaling does not happen in place. Even in clouds, as far as I'm aware, you can't vertically scale up in place. You have to shut down a machine, change the instance type, or terminate the machine and create a new one, right? So you can't do it in place. Or at least yet. Maybe in future releases, Kubernetes will support in place upgrades. But as of now, your resource will get recreated. So you have to keep that in mind. Okay, so a similar example like HPA, but here instead of deployment, we have a pod, right? So we start with these values for our CPU and memory request limits, like 0.1, 0.1 core or 100 millicores and 50 megabytes. And in VPA, we say that for this, so here we are defining the target. Target, the kind is pod and name is sample, right? So it takes the name from this metadata. So it's basically targeting at this pod. And we say that all the containers inside this pod, which as we can see, there's just one container, but you can have separate settings for separate containers, right? So if you have some kind of sidecar, you may not want to auto scale or upscale that sidecar, just upscale the application itself. So you can control which container inside the pod you want to change the settings for. And then again, just like the count we had given in HPA, that I want minimum one node, maximum three nodes, you give the minimum allowed CPU and maximum allowed CPU and memory, right? And as per the diagram, this recommender will keep a watch and come up with a value, right? That this is what the value should be right now. And the updater will evict the pod, and the admission plugin will kind of mutate the resource. Okay. Yeah, so there's one more setting, additional setting here, which is the update policy, right? So there are three values that are supported here. Recreate, where is it? Where is it? Yeah, recreate, initial, and off, right? So when you set this in recreate mode, it does exactly what we discussed right now, right? Automatically. It's like you just give it the access to do everything. When you set it in initial mode, it will apply the admission control to set the resource values when created, but it will never evict pods, right? So eviction is on you. You go and manually evict the pod whenever you are ready, and whenever the new pod will come up, the mutation has already been done by the VPA, right? And third one is off mode, which is nothing but think of it as a dry run, right? If you just want to see that if I set a VPA, what exactly is the desired value that VPA is coming up with, right? And it is kind of useful if you think about it, because this is what you get when you describe a VPA, right? So you get, so this is the important section here, the target section. You can essentially ask Kubernetes that if I ask you what would be the ideal CPU and memory, resource and request that you would set, and here is how Kubernetes will let you know that this is what I think is the target should be, right? So it's like when you set it in off mode, you can still see these values. All right.
Abdul, quick one. These evictions are hard evictions or soft evictions, which means that there will be any cooling time. Cooling time will be given to process the pending request, or it is just like that. When the condition met, it will be evicted.
Good question. I think when the condition is met, and if you have set it in recreate mode, the eviction will happen. But then there are other controls in Kubernetes like pod disruption budgets, right? So if you have a PDB, a pod disruption budget in place, you can ask Kubernetes to first create a new pod and then delete the old one, right? So that you don't see a significant outage. And
I
if you
believe, so sorry to interrupt you, Abdul, but other than that, for every pod or every container when we create, right, there also there's a control there, right? For example, the way any pod dies, right? So, for
Mhm,
example, a service points to three pods, right?
mhm,
And then let's say you want to scale down from the deployment from three to one, for example, right?
mhm,
Now, what is going to happen is for that particular pod which is about to get killed, right? So, first of
mhm,
all, no incoming connections would be given to that particular pod. So,
mhm,
basically, service would say that uh, these pods no longer under my endpoints. Though the
mhm,
pod may be running, but they are no longer an endpoint, which means no new connection would come to the pod, right?
mhm, mhm.
And then there are two settings which I'm kind of missing right now, but by default it is given few seconds.
Correct.
So that is in general, right? So even when you are scaling up, scale down, or whatever is happening in this case also, right? They were
Mhm.
still applicable,
Yes,
correct?
those are still correct. Those are still applicable, right? So,
So
like I
it's
said,
not going
Kubernetes
to,
has a bunch of controls. See,
yeah.
it will submit an eviction request to the API server. Now, API server will do like you said, right? But what happens is your active connections, if they have not drained by then,
Hmm.
right?
So that is,
Some
see,
of
that
the
is,
users,
so that is again the concept of microservices, right? You should
right?
not be kind of saying that if I put on Kubernetes, everything is done, right? It is as a thing, as a developer, you should be okay to make your application die at any point of time.
Right.
But being said that, there is already some time is being given. So whatever that I'm really missing those flag details there, or the settings there. But if you look at the pod spec, you'll get it there. So that way you would be given time, few seconds to basically close out your connections and so on. So that way it is already taken care. Hope that answered your question.
Does that answer your question? Who was it? Sai?
Uh, yeah, that's me.
Rajesh. Rajesh.
Thanks.
Okay.
Yeah, thanks for the clarifications.
Cool. All right. Auto scaling with custom metrics. So yeah, this is the fun and interesting part. And I guess there's a diagram here as well. So let's say, for example, instead of going with the CPU metric or the memory metric, uh, like we discussed, if you want to scale up an application based on the number of HTTP requests that are being served, or let's say if you want to scale up the pod instances based on the queue depth of SQS, right? The number of pending messages that are still to be processed. What you would want is you would want those metrics available via the API server to HPA, because HPA controller can only talk to the API server, right? And if you're using Kubernetes, you might most probably have Prometheus, right? Uh, uh, and Prometheus, I guess there's a community adapter, Prometheus adapter, which kind of does this linking for you. So any metric that you have available in Prometheus, you can essentially use it for your auto scaling, right? So if you send these data, right, if you send the HTTP count to Prometheus, you can essentially configure your HPA to say that, this is the custom metric that I want to auto scale based on, not just CPU, right? The only overhead, like I said, is a adapter component and a monitoring time series database of sorts, right? Which is Prometheus. There's no other alternate these days. Or if you're using a managed service, as uh, Nipendra was mentioning about KEDA, right? So KEDA is, I think, Kubernetes event-driven autoscaling. We forgot the full form. Yeah, Kubernetes or event-driven autoscaling. So what KEDA does is, instead of just Prometheus, you can essentially use any source for fetching the metric. It can be Datadog, it can be CloudWatch, right? It can be BigQuery, it can be Postgres, MySQL, anything, right? Uh, so it's more like a generic adapter, which allows you to auto scale based on custom metrics. I think this is an advanced level concept when it comes to auto scaling. And if you've not done HPA enough, this might be slightly overwhelming. But it's just good to know that you can scale on any metric that you want, right? If you're on Kubernetes, you're not bound to just CPU and memory. I guess that should be the takeaway from this section of the chapter. All right. This is a new thing that I learned. Cluster proportional autoscaler. Uh, so just like you have daemon sets where you say that I want one instance of, let's say, my log collection agent running on every node that comes up and joins my cluster. Uh, you can also say that based on the proportion, based on the size of the cluster, I want a few pods running, right? So let's say if I have 10 nodes, I want 2 pods running. If I have 100 nodes, I want 20 pods running, right? I don't want a one-to-one mapping, but I want to scale up, scale down based on the proportion, number of cores available in my cluster or number of nodes available in my cluster, right? You can use something called as a CPA. And I was wondering what would be the use case for this. And the book itself talks about a good use case, which is the DNS server, the core DNS server, right? I think by default it comes with 2 instances in EKS, but it might not be sufficient when you scale up to, let's say, 50 nodes, right? And you might also not need 50 instances, right? You might, let's say, need 4 instances. So you can do some kind of load testing on your environment, get some numbers, set some alerts, and based on that, maybe you could set up a cluster proportional autoscaler for such components inside your cluster. Again, this is a workload auto-scaling concept, not a cluster auto-scaling concept, right? And finally, custom auto-scaling. Essentially, you may or may not use these constructs made available to you by Kubernetes, like HPA, VPA, CPA, and whatnot, right? It can be something as simple as a cron job, which does nothing but modifies a deployment to increase the number of pods, right? So you are not bound to using these components if your demands are kind of very specific. I mean, not your demands. If your application's demands are very specific, and you know there is a pattern, right? So if you know that I need 50 extra cores on a Monday, and that's it, you can set up a cron job, right? And that would just add more. Uh, that would scale up your deployment on a Monday and then scale it down again on Tuesday. So yeah, I mean, custom auto scaling is not limited to these HPAs and VPAs. You can essentially write up and come up with your own solutions as well. But again, as discussed in the beginning of the chapter, adding any new technology or any new component to your system has a cost, and you should do the evaluation, the cost benefit analysis before jumping into any such solutions. All right, so that's about workload auto scaling. Next, we talk about cluster autoscaling, the underlying compute available to the cluster, the nodes, and cluster autoscaler is itself a component. I think it's is it part of Kubernetes project itself? I'm not sure, but it's an open source a pod that runs in your cluster, which does nothing but looks at the Kube API server and watches for pod pending events, right? And the moment it finds any pods that are pending, it will try to go and talk to your cloud provider and add a new node, right? Basically modify the auto scaling group in AWS, for example, right? So that's what it does. If it finds any pod that is in pending state, there's a diagram here. Yeah. So it continuously monitors your Kube API. Whenever there's a pod in pending state, it will try and add a new node to your auto scaling group. And whenever it finds that the resource utilization is kind of normalized or has reduced, it will also evict a worker node, right? And the way again it does is it will talk to your cloud provider and say that now my desired count for this ASG is 4 instead of 5, right? So that's what cluster autoscaler does. And again, this has more or less been replaced by a new component called Carpenter, which is supposedly more faster than cluster autoscaler. And I think AWS has already started recommending this as the default cluster autoscaler that you should go with, and also other cloud providers like Google and Azure, right? And It doesn't rely on the ASG, the auto scaling group. It directly talks to the API server and adds new nodes and remove nodes. And I think the benefit that you get out of it is when you create an auto scaling group in AWS, you have to predefine uh, the instance types and a bunch of other settings, right? So you can give a list of instance types that, for this auto scaling group, I need M4 large, M5 large, M6 large, right? And whenever the cluster autoscaler will try to scale up or scale down, that is a pool that you can pick the machine from. But when you use something like Keda, you can basically annotate your resource and say that I want this particular instance type for this deployment. So you are not restricted to that auto scaling group limitation. Essentially, you can just define that setting in your deployment, and you can say that I need a GPU for this deployment, and it will go ahead and create a new VM with a GPU. You can say that I need an ARM-based machine here, a Graviton VM, and it will create a Graviton for you, right? So it kind of eliminates the ASG layer.
So just
Yes, you're saying something?
yeah, so I have not used Carpenter at this point of time.
Mm-hmm.
So what you are saying is the difference between Carpenter and others are that you can specifically pick up the node for a given workload, is it?
Right.
Okay.
This might be a very trivial question, but can you tell me if taints and tolerations will have any impact on this setting, or how will that drive the auto scale?
Mm, can you describe the use case?
I mean, let's say if a pod is in pending state and that pod can go to only certain node,
Mm-hmm.
so how will the auto scaling be handled in that scenario, and that node is full?
Again, so Keda will be monitoring for pending pods, just like Cluster Autoscaler,
Right,
and it will try to provision the type of instance that you have tainted your deployment with.
right. Okay.
Yeah. I think we've recently done it for a client. I have not personally worked on it, but you can also define groups, right? It's not necessary that you need to have instance types with every deployment, right? You can also set defaults. You can just submit a deployment, and there'll be a default pool that will, be considered. Just like you have a default storage class,
Yeah.
right? You don't have to give storage class every time. But if you have a specific need, earlier with in case of cluster autoscaler, what used to happen is, let's say if I have by default there are Intel processors or AMD processors, right? Intel processors, x86, 64. Nowadays, Graviton has jumped in, right? So what you have to do is you have to create two autoscaling groups, one with Intel workloads, one with Graviton workloads. And let's say if you now have GPU-based workloads, so you create a third autoscaling group, and your
Right.
cluster autoscaler has to monitor all these three autoscaling groups, right? Or some people even suggest that you have three cluster autoscalers running, dedicated for each. Uh, so it used to become pretty tricky. Uh, those kind of issues become really easy with Keda.
Got it. Yeah. Yeah.
I think it does a lot more.
With Keda or Carpenter?
Sorry, Carpenter. My bad.
Yeah, I was wondering what. Yeah, yeah, correct, correct.
Carpenter. I think it does a lot more. It also does descheduling. Uh, so usually what happens is when the scale up and scale down is significant, right? Let's say if you go from 10 nodes to 100 nodes and back to 10, uh, the distribution of pods might not be the way you would have expected it to be, right? So ideally, let's say if you have three pods running for a deployment, you would want those three pods to be on three different nodes, right? But when those three pods become 100 pods and when they come back to three pods, there might be cases when you have two pods running on the same node, or you might get all three running on the same node. And, your the posture, the security or reliability posture is kind of weakened there. So there's a separate component called as descheduler, I guess, which kind of helps you solve this problem. It again keeps a watch on your running deployments, and it will make sure that whenever this kind of scenario happens, that if you have multiple pods of the same deployment running on the same node, it will kind of redistribute the workload. Now, these are all edge cases.
Yeah.
In 80% or 90% of the cases, you would not have to worry about this, right?
Right.
In 90% of the cases, you have to worry about where will the business come from. But then for remaining 10%, there are all these interesting challenges and problems which are there, and they are amazing tools. So I guess Carpenter also does the descheduling part, if I'm not wrong. I was reading one of the blogs. And again, it's an opinionated tool. Some people have suggestions or opinions that an autoscaler or a carpenter like component should not be doing all of this, right? It should just be scaling up and scaling down. But yeah, it's an open source project, and eventually the community will decide, where it goes.
And other than that, what I was sorry, just yeah. So really sorry, I just slept. We were discussing about the sorry. So let me come back if it comes. Sorry.
Yeah, sure, no worries. We've got full 12 minutes. 11. Okay. Yeah, so this is the component, Kubernetes descheduler. So if you have a copy of this book, maybe, and if you want more details, you can go through it, or if you want, maybe you can have a discussion in the later, sessions as well. But
Yeah.
again, like I said, these are very specific discussions. I mean, most of the folks don't really have this requirement.
Right. Right. Got it. Yeah. Yeah.
Yeah. All right. Okay, so this book also covers the fact that cluster autoscaler works not just with cloud APIs but also with cluster API. Cluster API, I think we covered it covered in one of the earlier chapters. It's a way to manage resources using cloud resources using Kubernetes, right? To manage other clusters using your management cluster. So the cluster autoscaler is compatible with cluster API as well, right? And again, very niche discussion. Okay. Yeah. So this is a typical YAML of your deployment, your cluster autoscaler deployment, and how it would look like. I think the important stuff is just here. You can forget about rest of it. It's just boilerplate, right? So what you're saying that I'm running cluster autoscaler. I'm running it for AWS. Uh, I'm going to run this in kube system namespace, straightforward. Here you give the min and max nodes for the autoscaling group, which is created in AWS, right? And you give the autoscaling group name. So this is the name of the ASG which is created in your AWS cloud, right? So this is how you configure. You also give the region, of course, which region your cluster is running, right? So this is how you configure cluster autoscaler in your cluster. And as far as I know, you cannot run two instances of cluster autoscaler. I think even if you run two, there's a leader election which happens, and only one of them is active at a time. Uh, so yeah, this is a deployment for cluster autoscaler, and it doesn't come by default in EKS. As far as I know, you have to install it separately.
Yeah, so I remember the flow there, right? So what you were discussing about that scaling down, right? So when the scaling down happens, the workload may not be kind of distributed as per the expectation or not
Hmm.
optimal way, correct?
Correct.
So for example, let's say, I mean, if the workload can run in 3 nodes, but you are running 5 nodes or 6 nodes right now, for
Hmm.
because of scaling down, you would be paying additional cost for those 3 nodes.
Right.
Ideally,
Right.
there should be something or someone who can look at that and then
Right.
reschedule the pods. I
I've,
think that
yeah. Yeah, I've
is
done
a,
that activity a lot. Yeah, manually just look at the nodes pods
hmm,
distributed across nodes, and just evict pods so that they get rescheduled somewhere else, and then
correct.
then cluster autoscaler triggers in and removes that node from the cluster. But I think as long as the average utilization is more than 50%, it will not do anything, right? Uh, which is not optimal, especially when you have a small number of nodes. Let's say if you have 100 plus nodes, I
Hmm,
guess doesn't really matter. But if you're dealing with 3 nodes, 5 nodes, the cost difference becomes significant, even with one
correct.
machine coming in or going out.
Yeah, that's true. And then there are these some tools are there which are specifically designed for that purpose, like a cast.ai or some other tools are there, right? If you
Mm.
install them, they would keep watching your resource consumption and they can even reduce down the load, the number of pods and so on there, right? So some of these
Yeah.
tools are helpful there to kind of do that. So
Right.
the schedule, I think maybe I have not used that, but uh, so these are going to help you to kind of make sure that if they need to kind of reschedule the nodes or to reschedule the pods to other node to
Hmm.
reduce the number of count of the node,
Hmm.
they would do it. Yeah.
Yeah. Yeah, true. I think I've also heard about cast. I have not used it, but this is rescheduler, right? As mentioned, and one of the use cases is like when some of your nodes are underutilized or overutilized, it kind of tries to rebalance the cluster. Because I guess Kubernetes does not do it by default. Like it does it
No, it
only
does
when
not.
you submit a new deployment. That's the only point where it will decide, okay, fine, which is the best place for this pod to go. Once it has gone, it will just make sure that the pod is up.
Yeah.
All right. Okay, we saw this YAML cluster autoscaler, but you guys should check out Carpenter. I guess it's pretty awesome. This is how they did cluster autoscaling. Okay, this is another interesting concept. Cluster over provisioner. Uh, and here, what you do is, so let's say if the spike in demand is very steep, right? You can think of, let's say, Reliance Geo streaming the World Cup final. You would suddenly have, let's say, 10x, 20x, or even 50x users spiking up during the final overs, right? And in that case, if you gradually auto scale, one node at a time, it might not be sufficient for you, right? Because the inflow is huge. The spike is like very steep. So in that case, what you can do is you can over provision your cluster with dummy pods, right? So look at the diagram here. Yeah. So let's say if you have three nodes and you still have some capacity with these three nodes, but you know that you are going to need some capacity soon. There is some event which is going to happen, right? So you would submit a new deployment with this dummy over provisioner pod. Now in this diagram, there is just one pod, but you can say that if I have four nodes, I need four more pods like these, right? So that I get four extra nodes that are created. Now, what does this dummy pod do? It will have ridiculously high resources and limits, right? Maybe almost the entire amount that a node has. But then the QoS, the quality of service flag, is set to -1, which means whenever a new pod comes in and it is in pending state, Kubernetes will see that this particular over provisioned pod, right, the dummy pod which we have, is a low priority pod, right? We are setting it to -1, and it is safe to evict this so that I can deploy this new workload that has come in, right? Now, what is going to help you with this? Uh, See, when you auto scale your cluster, the worker node comes in, right? So there is a booting time which is required. So a new VM is created. It will take, let's say, 2 minutes to boot up. It will take another 30 seconds to join to the cluster, right? So you lose 2.5 minutes there. And then your HPA will trigger in. Then your Docker image gets downloaded there, right? So this 3 minute, 4 minute delay can be painful. And again, these are edge cases. These are not for everybody, but it's a very real world scenario, right? So if you use these dummy pods, you can have extra nodes ready, right? So that whenever the HPA triggers, it has nodes which are already provisioned, attached to the cluster and available, right? And once your event is done, you can just maybe scale down this dummy deployment to 0, and all these dummy pods are gone, and eventually the nodes will be freed up. So it's a nice little hack, and again a good to know feature, because you might need it someday. Any questions? Any doubts with this, or is that clear? I think it's pretty straightforward, right? All right.
Yep, no doubts from.
All right. Awesome. So I guess, yeah, that's pretty much it to the auto scaling chapter here, and open for any discussions.
Yeah, discussion is for the next chapter for sure. Anybody want to pick up the next chapter? I think yeah, anybody, Rajesh, Atej, you want? I know it's the first time, but I think whomsoever asked the question about that what happened to the pod, right? Once what connections and all that stuff, right? All of that is covered in the next chapter. So, and of course, leading the chapter is definitely a way to learn more, right? So, if any of you want to take it, please let me know so that we can plan accordingly.
Sure.
Yeah, so it's next week, so you can ping me by tomorrow if you are willing to take it. You can take a look. Else, of course, we'll do this chapter for sure. And it's not that you will be alone. I'll definitely be kind of going over the chapter. So I'll be kind of, they say, as a backup for you and jump in wherever there is a need and all that stuff, right? So if any of you want to pick up, you can be a main person who talks about, but we'll back you up for whatever the requirement is there and so on. Right? So that
Yeah,
is
I
that.
guess, yeah, I mean, Nipendra or me, one of us could shadow you. So
Correct.
it's not that we are throwing you under the bus. It's just that the idea behind this is to make this more interactive and increase the participation of folks, right? Because, like I said, this book reading club is an excuse. The main goal is to basically, gel together with the community and, uh, spend some quality time.
And of course, as we know that, right, all of you would know, right, by teaching something, you'll learn more, right? So maybe by being selfish, you will kind of learn more about it. Yeah. Anyway, that's all.
Right.
That's okay. You can just ping me if you want to do it. That's okay. Down on no pressure. Otherwise, anyway, we'll meet next week to kind of go with the next chapter. Yeah.
All
Okay.
right.
Any
Great.
questions? Any feedback you guys have?